Now let's talk about shadowing, one of the most interesting and useful features in Rust. Shadowing is when you declare a new variable with the same name as a previous variable. This is not mutation. The old variable still exists in its scope. You're just creating a new binding that shadows it. But why would you ever want this? 3 reasons. First, it's fresh binding. Shadowing creates a completely new variable that happens to have the same name. Unlike mute, it protects the value from accidental mutation later in the scope. Second, the pipeline clarity. This is where shadowing really shines. Imagine you processing some input, you have a row string, then you trim it, then you pass it into a number. With shadowing, you can reuse the same meaningful name input. And at each stage, each let statement signals this is a new derived version of the previous value. It keeps your code clean without needing names like row input or trimmed input or parsed input. We're actually going to see in action in the next slide. Third, type flexibility. Change types. Here's something mute cannot do. With let mute, you can change a variable's value, but you cannot change its type. With shadowing, you can. For example, you can shadow a string with a U32 after parsing. The name stays the same, the type changes. Let's see shadowing in action. So here we're going to start coding. Let input equal string of space 32 space. So now we have this string. First thing we're gonna do is we're going to trim it, so we're removing the space. So we shadow it, input equal input dot trim. So this is going to remove the spaces. Then we're going to pass it into an integer, and so here we're going to change the type from string slice to U32. So we have let input U32 equal input dot parse dot unwrap. So now this is going to now change the type of the input, and we can now print it and we'll see it in action. Now let's print out at every stage. So we're going to print out input at the first stage. So print let's just call it first. So first stage we have input with which is a string with spaces, and then second stage it's going to be input with no space because we've trimmed it, and then final stage let's just call it third. Third we have input that has been turned into that is a new type, integer type. So when you print it, you're just going to be expecting the same number that's going to be shown. So we have first 32, and you can see this first 32 has a lot of spaces, had a lot of space compared to the 32 here and 32 here. This is because we had some extra space. Second, we've trimmed it, and third is just an integer type, and we can actually play around with it. Let's say let's create an integer. Let num equal input plus 6, and we're now going to print num. Let's call it addition third addition. So here we expect it to run because it's an integer. It's 38. But what if now we do that there? We do the same with the others. So before we turn it to an integer, we have let num. Remember, we're also shadowing num here. By the way, so here it's second addition. So here we're expecting an error. We're actually seeing an error here because we're adding an integer to a string, which is not going to work. And the same with this. If you do it here as well, we're going to have an error. You can already see the warnings here. Cannot add integer. But on the third, it works because we've changed the type to a U32. Shadowing is safer than mute for transformations because each step creates a new immutable binding.